Welcome to the third part of our Unit 2 review. Let us continue on here with question number 8. The accompanying data table here on the right with student and pulse represents the pulse rates in beats per minute of 5 students. We want to treat these 5, not 9, 5 students as a population. And we want to compute the z-scores for all the students and compute the mean and standard deviation of these z-scores. It should be noted that the one on the test is going to be 9, but we are only doing 5 in this particular video. But the same idea still applies. So let us, you could certainly do that by hand if you wanted to, but why don't we open that up inside of StatCrunch so we could see how to do this. Okay, I have all those pulse rates in here. So to do this just as we did the last time we had to do a z-score like this, we are going to data, compute, expression. And we are going to use the following expression. We are going to take each value of the pulse column, subtract the average or the mean of that pulse column. We have to surround the entire thing in parentheses, divide by, we are going to treat this as the population. So this would be the unadjusted standard deviation, so USTD of a pulse column. All right, so in parentheses, pulse minus mean of pulse divided by the unadjusted standard deviation of pulse. And compute should give us these 5 z-scores, and we would have to round them to 2 decimal points each. So just to give a quick rundown of that in our document. Let me give myself a little bit of room here so I can write it on the other side. So for student 1, based upon what we got, that student's z-score will be 0.81. Student 2 was negative 1.16. Student 3 was negative 1.16. Oop. Negative 1.16. Student 4, positive 1.27. And then for student 5, that was 0.23. So 0.81, negative 1.16, negative 1.16, 1.27, and 0.23 would be the 5 standard population z-scores here. On the test, it's going to be 9. Please keep that in mind. And then we want the mean and standard deviation of the z-scores. Mind you, you could calculate that in StatCrunch if you wanted to. But we know something, a special property of these z-scores. The mean of the z-scores is always, if we were to take the mean of the entirety of the z-scores, we should get a mean of 0. And the standard deviation, population standard deviation of these z-scores should be 1. Mind you, if we were to actually calculate it based on the numbers we got inside of StatCrunch, these might be slightly off, but we know these are the properties as we have previously seen them. For question number 9, we have this side-by-side box plot, and we want to use it for parts A through C. So which variable here has more dispersion? And then, of course, y. So based on here, the box plot for x is kind of small, but the box plot for y is a lot larger. So this will be variable y. And why is that? The interquartile range. Interquartile range of the variable y is larger than that of variable x, which we could see in our graph. Variable x. We could see that in our graph. We want to describe the shape of variable x, support or position. Well, it's going to be symmetric. The median is the center of the box. And the left and right whiskers. For that matter, so is the first quartile and the third quartile being the same width, but in this case, left and right whiskers are the same length. The left and the right whiskers are the same length in this particular case. And then finally, for this question, we want to describe the shape of the variable y and to support our position. So variable y here, the left side is longer than the right, so this would be skewed left. And then why is that? Well, the median is right of center. In the box. And the left whisker is longer than the right whisker. For that matter, the first quartile in the median is a bigger difference than the third quartile in the median. And then the last question that we have, based on this data to the right, representing the age of world leaders on their day of inauguration. We want the 5-number summary and to construct a box plot for the data. And comment on the shape of the distribution. So we need the data in here. Let me quickly toss that into stat crunch for us. Okay. So we are going to go to stat, summary stats columns, and choose a variable 1. And for a 5-number summary, we want the median, minimum, maximum, first and third quartiles. And it should be noted, as we have discussed before, that if you do not use StatCrunch for this, the numbers are unfortunately going to be off and you would be marked wrong. So please be aware of this. But from here, the minimum is 46, first quartile 48, median is 55, the third quartile is 61, and the maximum is 64. We can also look at that box plot. Graph, box plot. And doing so, once we select a variable, it gives it to us like this. Right? And we could kind of see the shape there, right? I mean, there's a little bit of difference with the whiskers, but not much. This would be a roughly symmetric distribution. But let us write all this down. So the minimum was 46. First quartile was 48. The median was 55. The third quartile was 61, and the maximum was 64. And as we saw, the distribution is roughly symmetric. Again, not perfect. Then again, as I mess up the G here, then again, how often is it going to be exactly perfect? So the distribution is roughly symmetric. Okay, that is the last bit here of this unit 2 review. Let me know if you have any questions or concerns. Thank you.